The job description of a data scientist reflects a highly analytical and strategic role that has become essential in modern organizations. As companies increasingly rely on data-driven decision-making, the demand for skilled professionals who can extract meaningful insights from complex datasets continues to rise. A data scientist is not just a number cruncher or a programmer. They are problem solvers who blend statistics, computer science, and business acumen to answer critical questions and optimize outcomes. Data scientists work across industries such as finance, healthcare, retail, tech, and manufacturing, among others. Their work often involves interpreting large volumes of structured and unstructured data to identify patterns, build predictive models, and guide strategic business choices. They collaborate with engineers, analysts, managers, and executives to turn raw data into knowledge and ultimately, value. The responsibilities of this role go far beyond simple data collection. They require innovative thinking, communication, and the ability to implement solutions in real-world environments. Core duties and responsibilities of a data scientist. At the heart of the job description of a data scientist lies the ability to analyze vast and complex data to provide actionable insights. A data scientist starts by understanding the problem they are solving. This may involve increasing customer retention, forecasting sales, detecting fraud, or optimizing logistics. Once the problem is well defined, the data scientist gathers relevant data, cleans and processes it, and explores it to understand trends and relationships. Data preparation is a major responsibility. Often, the data gathered from various sources is messy, incomplete, or inconsistent. The data scientist uses data wrangling techniques to clean and transform the data into a usable format. This can involve dealing with missing values, outlier detection, normalization, and feature engineering. Once the dataset is prepared, the data scientist conducts statistical analysis or applies machine learning techniques to derive insights. This may include regression analysis, classification models, clustering, decision trees, or deep learning algorithms. The selection of the right model depends on the problem and the nature of the data. Beyond building models, data scientists must evaluate and validate them using metrics such as accuracy, precision, recall, F1 score, and others. Once validated, they often deploy these models into production environments using tools such as Docker, Flask, or cloud platforms like AWS, Azure, or GCP. Equally important is communicating results. A data scientist must present complex findings to non-technical stakeholders through visualizations, dashboards, or concise reports. Using tools like Tableau, Power BI, or Matplotlib and Seaborn in Python, they transform statistical outputs into compelling narratives that inform business decisions. Skills and technologies required for the role. The technical requirements in the job description of a data scientist are extensive and ever-evolving. Mastery of programming languages like Python and R is essential, as these languages are widely used for data analysis and machine learning. Proficiency in SQL is also necessary for querying databases and retrieving structured data. A solid foundation in statistics and mathematics is indispensable. Concepts such as probability, linear algebra, hypothesis testing, and optimization are used daily. Understanding when and how to apply statistical techniques is critical to deriving meaningful conclusions. Knowledge of machine learning libraries and frameworks, such as scikit-learn, TensorFlow, PyTorch, and XGBoost, is often expected. These tools allow data scientists to build and train complex predictive models efficiently. Familiarity with APIs, scripting automation, and cloud platforms adds significant value. In addition to technical prowess, soft skills are critical. Communication, problem-solving, and curiosity are essential traits. A data scientist must be able to interpret business problems, ask the right questions, challenge assumptions, and translate numbers into practical recommendations. Collaboration is also key, as data scientists rarely work in isolation. Types of projects and application areas. Data scientists are involved in diverse types of projects that vary by industry. In e-commerce, they might work on recommendation engines that personalize shopping experiences. In finance, they may build credit scoring models or algorithmic trading systems. In healthcare, data scientists assist in predictive diagnostics, treatment outcome modeling, or even genome sequencing analysis. In the realm of logistics and supply chain, data scientists forecast demand, optimize routes, and reduce operational costs. In marketing, they help analyze customer behavior, segment audiences, and improve campaign targeting. Social media companies use data scientists to enhance user engagement, detect abuse, and personalize content feeds. Across all these applications, a key principle remains constant: data scientists must transform raw data into insights that generate business value. This requires not just technical execution but a strong understanding of the domain in which they operate. Collaborations and workplace dynamics. Data scientists often function as part of cross-functional teams. They work alongside data engineers, who focus on building the data pipelines and infrastructure that enable scalable analysis. They collaborate with business analysts to align data findings with organizational goals. Product managers and executives rely on their insights to guide strategy, and software engineers may help integrate their models into larger platforms or applications. In many organizations, data scientists contribute to building data-driven cultures. They help educate teams about the value of analytics, train employees on data literacy, and advocate for better data practices across departments. Their ability to bridge the gap between raw information and strategic vision makes them valuable agents of innovation. Workplace tools can include Jupyter Notebooks for development, Git for version control, and collaborative platforms like Confluence or Slack. Agile methodologies are often used to manage their projects, and tasks are typically broken into sprints with regular stand-up meetings. Educational background and certification. Most data scientists hold a bachelor's degree in a related field such as computer science, mathematics, statistics, data science, or engineering. However, due to the complex nature of the job, many also have advanced degrees, masters or PhDs, in quantitative disciplines. This academic training helps build the mathematical intuition and research skills needed for complex data problems. In addition to formal education, there are numerous certifications that can boost a candidate's credentials. Examples include Google's Professional Data Engineer, IBM Data Science Professional Certificate, Microsoft Azure Data Scientist Associate, and others. These programs offer structured learning and demonstrate proficiency in relevant tools and practices. Online learning platforms like Coursera, edX, and Udacity offer specializations in data science, often including capstone projects that simulate real-world applications. These resources allow aspiring data scientists to continually upgrade their skills in a rapidly evolving field. Evolving nature of the role. The job description of a data scientist is constantly evolving. As data collection methods improve and AI technologies become more advanced, data scientists are expected to handle more complex and nuanced datasets, including text, images, audio, and video. Natural language processing, NLP, computer vision, and deep learning are becoming increasingly relevant in the field. Moreover, ethical considerations are playing a bigger role. Data scientists must ensure that models are unbiased, privacy is protected, and results are used responsibly. With regulations like GDPR and other data privacy laws, the need for responsible data science practices has never been more important. Automation tools are also reshaping the workflow. Tools like AutoML help streamline parts of the model building process, allowing data scientists to focus on more strategic aspects of analysis. However, the need for human oversight and domain knowledge remains irreplaceable. Conclusion. The job description of a data scientist highlights a role that blends technical expertise, analytical thinking, and business insight. Data scientists are at the forefront of transforming raw data into strategic value, helping organizations stay competitive in a data-driven world. From cleaning data to building machine learning models and presenting insights to stakeholders, their responsibilities are both broad and deep. They must possess a balance of skills, ranging from statistics and coding to communication and curiosity. Their contributions are critical across industries, as organizations strive to understand customer behavior, optimize operations, and forecast trends. In essence, a data scientist is more than just a data professional. They are a decision architect, a storyteller, and a builder of predictive systems. As the role continues to evolve with technology and societal demands, data scientists will remain vital in shaping the future of businesses and the solutions they provide.